within the Centre of Excellence, we are engaged to carry out fundamental and exploratory research into the development of new electromaterials. That's materials that conduct electricity.
We have people from all disciplines: physicists, chemists, metallurgists, ceramicists, engineers, all working together to solve important problems.
So we're particularly interested in the application of these new electromaterials in the areas of energy and in medical bionics. The areas of energy and medical bionics are critical to all of us in our everyday lives.
So we try to devise ways to harvest energy that would normally just be wasted.
We are developing new solar cells based on these materials. We're also looking at developing water splitting technologies where we can use sunlight to generate the important fuels of hydrogen and oxygen. In the area of medical bionics, of course, there's been tremendous advances already. We work very closely with Professor Graham Clark, the inventor of the cochlear bionic ear implant.
One of the issues that we have at the moment is the connections between our electrode system and the nerves inside the inner ear. And so we need to be developing new methods of connection. The opportunity we'd have with conducting polymers in particular would potentially change the rules.
So as these devices become available, they have direct and immediate application.
Electrochromics are devices that change colour so that they lighten or darken.
For us in the automotive field, electrochromics is associated generally with interior mirrors that auto-dim, providing a safety feature for the driver. So we are working with the team here to develop that product.
The new facility is a processing and device fabrication facility, or a prototyping facility.
Well, I think the new building is actually quite fundamental to the transition of innovation into the marketplace.
It will allow us to scale up in the materials processing end and in device fabrication to develop new machinery that enables us to effectively and efficiently turn our new materials discoveries into devices as quickly as possible.
So we're going to use state-of-the-art technology, inkjet-based technology that's in these systems, and use that to process materials that we develop in-house ourselves.
We have joined forces with collaborators around the world to develop this customized printer.
So these work just like any other inkjet printer, except we can swap out the ink with other functional materials. So for example, we can print living cells with these inkjet printers to create tissues.
The capability here is something that you can't have in-house.
One thing that you can see when working with industry partners is that being able to produce a prototype, a device that they can relate to, something that they can handle, they can touch, they can actually see how something works. There's no better demonstration of your capability than to do that.
The facilities are world class, they're second to none. We have conventional machinery as well as machinery that's being developed specifically for the tasks at hand. So it presents researchers with unique opportunity where you can be involved right from the start, designing the right molecules to make the right materials and turn it into devices all in a streamlined facility, and we have the capability to do that.